All right, thanks for tuning in. We're going to talk about the Pythagorean theorem and the distance formula today. I'm not going to go through and do every single problem from the notes, so be sure you're using the answer key on Schoology in conjunction with this so you can kind of get a full picture, because I will be skipping some of the problems just because I don't want the video to be, 20 or 30 minutes long. So what is the Pythagorean theorem? I'm sure you've heard the formula before. A squared plus b squared equals c squared. And we use that for right triangles. So this is A, B, and C. You can find a missing length. That's what this is doing. It's finding a third side length. Probably should write that in. And if you want to state that in words, you would say the Pythagorean theorem says that the sum of the squares of the legs of the right triangle is equal to the sum of the square, or just is equal to the square of the hypotenuse. So remember, the longest side is the hypotenuse from when we did hypotenuse leg, and then the other sides are just called legs. The legs touch the right angle, the hypotenuse is across from the right angle. Okay? So a few other things. You have to have a right triangle, and C is the hypotenuse, or the longest side. Okay, so it's really important that you remember that C is the biggest side, and it is across from the right angle. The right angle kind of points to where C is. Okay. All right, I'm going to do 1 and 2 for you, and then I'm going to leave 3 and 4 as practice. You can look in the key. It says for 1 to use simplest radical form. So let's set up the equation. So a squared plus b squared equals c squared. So I'm going to call this C, has to be called C. And then the other two you can just call A and B. Doesn't matter which one's A, which one's B. But C matters. It's the longest. So this is going to be 6 squared plus 3 squared equals x squared. This is 36, and 3 squared is 3 times 3, which is 9. So everything's gearing up to us having a number on one side, and then the x squared alone on the other side. How do you move from here? You take a square root, because that's the opposite of squaring, and that will make this become an x. Okay? And the square root of 45, well, that'd be a good problem from the last section. Remember that this is 9 times 5. Why do I say that one? Well, because 9 is on our list, right? Remember, our list was of those perfect squares. 9 is on the list, so I know that this 9 can come out and become a 3. Okay? So that's the answer. Okay? And we'll be doing more practice in class on radicals and stuff like that. But that is the length of this side right here. Okay? But most of the time, we probably are going to want a decimal, especially for like measuring something or doing a project or with wood or outside, or measuring lengths or dimensions of a garden you want to make or something like that. Probably going to want a decimal. So let's do that here. It says for this question, round to the nearest tenth. So we got 14 squared plus 22 squared equals x squared. Again, so x is the hypotenuse in both of these. So to help you through the math, if you type this in, you get that. If you type this in, you get that. You got to add them up. 680. Okay. And if you take your handy calculator and type in the square root of 680, you should get 26.1. Around 26.1. Okay. Keep in mind that x is not always over here. X can be I'll set this one up for you, and then we'll move on to the next question. But in this case, this is c. So it can be the case where you have a setup like this, and the x squared is kind of in the middle somewhere. Okay. So to solve that, you're going to apply the squares to the numbers. You're going to get some more decimals. You're going to move this over here by subtraction, and then you'll take a square root. Okay, so go ahead and try that now, and try and do number 4 as well, and you can use the key. Okay. Here it wants us to kind of draw a picture and then solve. So I'll go ahead and do, I'll do 5 and 6. You can try number 7, but this is a very popular right triangle where it's 3 and 4. It would be 3 squared plus 4 squared equals c squared. So that's 9 and 16, which is 25, which means that c is 5, because 5 squared is 25. So that's actually a very extremely popular right triangle. It's the smallest triangle in like that you could draw that has whole number sides. Okay, so it's very important triangle. Okay. Okay, and if we had this question where B is 20 and A is question mark, we don't know that, and then C, which is the hypotenuse across from here, is 23. What's A? Well, it would be A squared plus B squared equals C squared. Okay, this is 400, and this is 529. So A squared is 129 after subtracting, and by taking a square root of both sides, we isolate A. So you want to think about, is this in simplest form? Well, think about 129. Again, that doesn't stick out to me much at all, so I would just maybe try 3, try 7, try and divide. Turns out 3 works. It goes in 43 times. And 43 doesn't have any factors that aren't 1. Okay. So we circle this one too. And when you have this, it means that 129 doesn't have any squares hiding in it. It's just a kind of a simplistic number. So this is the answer. This is simplified. It can happen sometimes. Okay. So go ahead and try 7. You should get 16 after doing that. Okay. Does a squared plus b squared equal c squared? Okay. Well, a squared plus b squared, the left side, is equal to 4 squared plus 6 squared. 4 times 4 is 16. 6 times 6 is 36. So that left side is going to be 52. The right side, c squared, is 7 squared, which is 49. Okay, so no, we do not have that a squared plus b squared equals c squared. So because a squared plus b squared does not equal c squared, the triangle is not right. That's actually called the converse of the Pythagorean theorem. Pythagorean theorem says if you have a right triangle, a squared plus b squared equals c squared. Well, the other way around would be, well, actually, I take that back maybe. I'm not sure we would call that. I don't think I've stated it right. Yeah. So the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. But it turns out that you can also go this way. If a squared plus b squared equals c squared, then the triangle is right. And it turns out that since we have both directions, if you don't have they're kind of one and the same, right? So if it's not equal, it's not right. And if it's not right, it's not equal, without diving too much into it. But that's technically the other direction. Anyhow. And then I like this word problem here, and then we'll do a few distance questions. So we have a big pond, and we got point A and point B. Okay. So to get from A to B, you're going to have to walk right through that pond, which is not advisable. So instead, you're going to walk 34. So here's north, east, south, west. Never eat soggy waffles or whatever you're trying to do. However you remember that as a kid. And this is 41 meters east. So we actually have a right triangle. So how many meters would be saved if we walked through the pond? Well, I think it's clear that if we go around, it would be 34 plus 41, 75 meters. We need to know how much it would be to walk through. So, and we think it should be less, right? I mean, the shortest distance between 2 points is just the line connecting them. So we hope that this is going to be a shortcut, but we're going to have to walk through all the water. So how would you find this? Well, this is a C value because it's the hypotenuse, right? It's the longest side and it's across from the right angle. So we could set up a squared plus b squared equals c squared, which would be 34 squared plus 41 squared is c squared. And it turns out that this is going to be these very large numbers that we should use a calculator for. If we add them up, we get this. And look at the point we're at now. We got c squared by itself, but it's stuck, right? The c is stuck under the square. In order to free it, we have to take a square root. And we're just going to consider the positive answer. So I think that c is around 53. Okay. So if we just walk through, it would be 53 meters, right? So the distance saved is 22 meters. All right. Okay, so that's it on Pythagorean theorem. Let's talk a little bit about the distance formula, and that'll be it. Okay. If you don't know it, this is the distance formula. Very long equation that tells you how to find the distance between 2 points, right? So we could practice that here. We could say, all right, this is going to be x1, y1, x2, y2, and we can say the distance is the square root of the difference of the x's and the difference of the y's squared. Okay. So plug in the numbers. We're going to get x2, which is 6 minus 1, 6 minus negative 2. So we're going to get 5 squared plus, let's see, make sure I got this right. Hold on. I think I made a mistake. I always make a mistake with this. I'm sorry. y2 is 2. So this is actually going to be 4 squared. You guys with me? So this is 25 plus 16. So it's the square root of 41, which cannot be simplified. 41 does not have any good factors. So this is about 6.4. And calculator tells us that. Okay, but the formula is nice. I always seem to mess it up personally. So if there's another way to do it, I'm going to do it. And that's with a graph and with the Pythagorean theorem, a picture, right? The picture could be very meaningful. And since we just studied the Pythagorean theorem, if I plot my points here and here, and I want to find the distance of this line right here, we could just make a right triangle. So I'm going to call this distance C, and I'm going to make a right triangle. Okay. count the blocks. This is 4, and this is 3. Right? So you would just set up like it's a problem from the notes. You would just say, okay, 3 squared plus 4 squared equals c squared. So we get that c is just 5. Okay? So rather setting up the huge square root, right? If we can have a picture, Pythagorean theorem may be the way to go, because we just count boxes and then just set up a squared plus b squared equals c squared. Okay? So it's actually what's neat about this is, so I want you to kind of just have some exposure to this. And what's really neat is that these two methods we just did are identical. They use the same formula, because if we apply Pythagorean theorem on this triangle, it would be this squared plus this squared equals d squared, right? This is just talking about, it's the distance. It's just counting blocks, right? If we had blocks here and this was at 1 and this was at 5, it would just be saying, okay, this is just the distance between 1 and 5, which is 4, right? So although it looks complicated, that difference there, these differences here, are just saying like, oh, count the blocks between the two y values. But then what's really cool is if you square root both sides, and because distance is a positive thing, it's just the square root of this. That's the distance formula. It's just using Pythagorean theorem. Okay? So I think Pythagorean theorem is pretty straightforward, whereas distance formula, I'm going to forget it, you know? So really put a lot of value in drawing a picture and finding the distances with Pythagorean theorem, okay? So you can practice those down there. The answers are online already, and you can practice the homework too. Plenty of practice for you to work through, and hopefully feel comfortable with this stuff.